right there. So this is my line to nowhere. When I take and I swing this force 30 degrees, I'll get here. 80 cosine 30. Agreed? Now I gotta swing it to the XYZ or parallel to the XYZ. Agreed? So if I take and swing it, cosine 40 puts me right here. So this is 80 cosine 30 cosine 40. Well, that line is what? That's parallel to my y. So that's my j component. And if I swing it here, which is sine of 40, I'll get to a line that is parallel to my x. So technically, I should be able to say, for this problem anyway, 80 cosine 30 sine 40i. So my f is 80 times cosine 30 sine 40i plus cosine 30 cosine 40j, and then minus sine 30k. Remember, we double project only twice, not 3 times. It could be I and j, it could be I and k, it could be j and k, depending on how the force is set up. But you'll double project twice and only twice, right? So if you work out these numbers, you're going to find that f is equal to 44.534i plus 53.073j minus 40k. Chapter 2. I have done nothing other than chapter 2. What's in chapter 2? Hey, how to take a force, find a resultant, right? Using components. Then we did 3D, double projection, alpha, beta, gamma, and then we did position vector. When we're given a bunch of distances, get everything in terms of IJK using the position vector. So I've just done a double projection problem. Moment about A is equal to R cross F. It's interesting to me that everybody tells me, yeah, I'm studying, I got this, I know this, I'm ready. And then they come into my office and I ask a very, very simple question. And then 2 people I asked the question of got it wrong. I said to them, moments equal to F cross R. True or false? False.
False.
They said true. So you can't tell me you know what you're doing if I trip you up on a simple thing like that. True or false? Order matters in a cross product. Because A cross B does not equal B cross A. How are they equal? They're the negative of each other, right? So when you write F cross R, that would not be correct because I'd have a negative. So notice I said R cross F. Well, I got the F, I need an R. What's the R? Well, I need to go from my moment center to here. You can't see it. I need to go from my moment center to here. Correct? Now, one way to get there is to go 400 in the Y, 300 in the X, downward 200 in the Z, and over 250 in the X. So really my R should be 0.55i plus 0.4j minus 0.2k. This is in meters. Everything shown there was in millimeters. So literally I went 400 in the y, right? I went 300 here. I went downward 2 and over 250. So 250 plus the 300 gives me the 55, which is 0.55. 400 is 0.4 in meters. And I went downward 200, which is 0.2 meters. And that's my R. So now I have this determinant, I, J, K, of 0.55, 0.4, and a minus 0.2. This would give me 44.534, 53.073, and minus 40. Now, I don't care how you do it. You can do it manually, you can do it using your calculators, it doesn't matter. But I do want to see this setup on the test or on the quiz. I would like to see the setup minimum. Okay? Then you can sit there and say, hey, by my calculator, I get MA is equal to minus 5.386I plus 13.094J plus 11.376K. That's my MX, MY, MZ. Okay? Now if it just says find the moment, you're fine. That's it. Done. I don't need anything else from you. But it says find the magnitude and direction of the moment. Then I need the magnitude of this moment, which is square, square, square. Out of the take the square root. 18.162. Alpha, cosine inverse of minus 5.386 divided by 18.162. That's 107.25. Beta is cosine inverse 13.094. Divide this by 18.162. 43.86 degrees. And gamma, cosine inverse of 11.376, divide this by 18.162 is equal to 51.22 degrees. So if I just say find me the moment, then just give me IJK. If I ask you to find me the moment and direction, then you need to give me 18.162 with the alpha, beta, gamma shown. You with? Who's not with? Can everybody do a moment that is a cross product? That's what I want to know. Because you're going to have to do it on the test. Yeah. What's that? Sure. Newton meters, pounds, feet, or foot pounds. Yes, of course there's units. So this one would be Newton meters. Yep. Questions? Okay. Next problem. Wait, we just did this problem. Did you? What the hell is the difference? What's that? The coordinate system is different. What was the first thing I told you you must do when you see a 3D problem? Check the coordinate system. See, it looks the same, but it ain't the same. The numbers are going to be the same, they're just going to be in a different place, different order, different position. So if you look at the solution to this one, here's the solution to it. The value is still 18.162, but notice the difference. And let's see if I can put them together. Notice the difference in the moments. The first time we did it was the I was minus 5.386. Due to the coordinate system change, that 5.386 is no longer the mx, it's actually the mz. And due to the coordinate system, 13094I was the j here. So it may look the same, but your coordinate system changes the placement. The numbers are the same. The numbers haven't changed. 11, 13, 5. The placement has changed. And you say, hey, that's the same thing. No, it's not the same thing. No. Because outside in the real world, if you say, hey, my mx is 5.386, when it really should have been 13, that could be a disaster. That might not be so good. Notice the angles are pretty much the same. Alpha is 43.86. Here is 107. Over here is 51.22. When we solved it, that was 43. So yes, you get the exact same numbers, but their location is what matters. And that's what's going to matter outside the real world. You can't tell your boss, hey, the moment in the x is 13 or 5, when it should have been 13. 13 and 5, that's a big difference. When you're talking about kicks. Okay? So I'm trying to emphasize to you, when you get a 3D problem, first thing you check that damn coordinate system. The problem looked exactly the same, but it really wasn't. That's what I'm trying to tell you. Okay? Who's not with me? All right. Next problem. I want to do, I want to do this one. Nobody thinks about it, but you stick the shovel in, you hold it here, and you pull. You're pulling down on one and you're pulling up on the other. If they're equal forces, you're going to generate a couple. Go generate a couple. Here it so happens that the forces are not equal. One's 12, one's 30. And I want to find what is the moment being generated at this point A right here. Got it? No, it's not a 3D problem, so will I do R cross F for it? No! No need to do R cross F. Can I do R cross F? Yes. But I don't want to do R cross F if I don't have to. It's a 2D problem, all I have to do is force times distance. Okay. Well, I don't want to go through the process of trying to find the perpendicular distance. So what I'm going to do is I'm going to create components of this and components of this. So I got two components. One's in the red and the other's in the green. What can you tell me about this component here? Its line of action goes through A. That's creating nothing. What about this component? Same thing, creates nothing. So what I really have is only this, which is 30 cosine of 30, and 12, this would be 12 sine of 65. That right there would be sine of 65. Yes? Now, I'm going to do some moments. Some moments at A is equal to, and I'm going to take counterclockwise positive. This distance is 800 plus the 450. That's going to be 12 sine 65. That is my force. I need a distance. That distance is the 0.8 plus the 0.45. 0.8 plus the 0.45. This is, of course, in meters. Now I got to put a sign on it. Well, if it's going this way, what do I have? Positive. And then I have 30 cosine 30. That's the force. I need its distance from here to here is 0.45, positive or negative. Well, if I take this force and move it just like to here, by principle of transmissibility, take the arrow and I go around A, that's a negative, because it's clockwise. End result, if you do the math, is 1.9 Newton meters counterclockwise. Again, nothing fancy, but I want to make sure you're able to do a moment. Moment 3D, R cross F. Moment 2D, force times distance. Usually, by default, we go to Varignone's theorem when we do 2D, because it's the easiest way to get to the distance. Okay?
Yes, sir.
Yep,
Can you put your answer in millimeters?
I can, but I usually default to meters or feet. That's my default. Why is that my default? That's my default because if I have to change from mass to weight, I know G in terms of feet. I know it in terms of meters. 9.81 meters per second squared, 32.2 feet per second squared. So I kind of default to feet and meters in case somewhere I have to do a G to get a mass to weight. I'm sure I could, do millimeters in terms of G, but I don't want to go through that hassle. I don't know it off the top of my head. What is G in millimeters per second squared? I don't know. Could I find it? Yeah. But it's so much easier just to say meters. Millimeters to meters, you're just moving the thing, right? All right. Next problem. Here you go. How to take a simple problem, make it Norritized. This is a Norritized problem. Why? Look at the number of parts. Parts A, B, C, D, E, etc. So, first of all, is it a 3D problem? What's the first thing you look for? Coordinate system. Hey, how did it give me information in that coordinate system? Did it give me alpha, beta, gamma? No. Did it give me a double projection? No. Did it give me a bunch of distances? Yes. So I got to go through the 5-step process in order to express all the forces, this cable tension AC, this cable tension AB, in terms of IJK. Yeah? Notice what it asks you for. It says find numbers AC and AB in Cartesian vector form. i.e., give me IJK format. That's the 5-step process. Notice part B. Hey, tell me the magnitudes of AB, AC, and W to maintain equilibrium. Tired? Sleepy? Yawning? You woke up too early. What time did you wake up? Did you go to sleep? 2. Second part is chapter 3, 3D. Some force x equals 0, some force y equals 0, some force z equals 0. Next. Hey, tell me the angle theta between tables AC and AB. Oh, I'm sending you back to chapter 2, section 9. 3 uses of the dot product. The first use was find the angle between 2 tables. Next, tell me the projection of force AC onto line DE. Unit vector DE dotted with the force FAC. That's the second use of the dot product. Yes? Moment of AC about O. R cross F. What R? I'm taking AC. I have really 2 choices and go from O to C or from O to A. Which one would be easiest? O to A, because O to A is nothing more than 2 plus 6, 8i. 8i is 0j, 0k. The more zeros I have in my determinant, the easier it is to solve by hand. Remember, I don't have a calculator. I have one of those TI's 30 something. Really basic. Was here last
2.
no longer here. So I do everything by hand, so I always want to pick an easy eye for myself. Add. Here we go. F. Project F moment FAC onto line DE. What did I just do? Hey, chapter 4, section 5 coming your way. Right? So notice how easy it is to incorporate everything. Not that hard. Now, all I did here was incorporate one type of force, which is the position vector. But I could have made this force be a double projection. I could have said, hey, this angle here is 60, this angle here is 50 or 80, and then leaving out what? If I gave you this as alpha, that right here is 80, what did I leave out? That's alpha, beta, what did I leave out?
Gamma.
Gamma. Oh, shit, you left out gamma. What do? Cry, panic, call the teacher names? Yeah, okay, that's fine. But it ain't solving the problem. You go to my identity. Yeah? So, easy to change it up and incorporate lots of stuff. Easy. Very, very easy. I just showed you a very simple problem, and I just added stuff to it to make it Noratized. And you can do that with any problem in the textbook. Any of them. Somebody got a hard copy of the textbook? Hard copy? No. Okay. Anyway, let's do this problem. So the first thing I need to do is get everything in terms of IJK. So, I need the coordinates of A, which is 8, 0, 0. I need the coordinates of C and the coordinates of B. 0, 6, 8. Over here, this is 0, 3, negative 4. By the way, the coordinates of D are 0, 0, and 8. Coordinates of E are 2, 0, 0. So I just took all the distances and made coordinates out of every important point that's on the damn diagram. Now I'm going to say RAC is equal to XC minus XAI plus YC minus YAJ plus ZC minus ZAK. RAC vector is minus 8I plus 3J minus 4K. Magnitude of this is 9.434. Therefore, FAC vector is FAC magnitude times minus 8I plus 3J minus 4K divided by 9.434. That tells me FAC is minus 0.848 FACI plus 0.318 FACJ minus 0.424 FACK. There is FAC in terms of IJK. What's the first thing you want to do with a 3D problem? Get me everything in IJK format. It's the first thing you want to do. All right, repeat. I got to repeat it. RAB. XB minus XAI plus YB minus YAJ plus ZB minus ZAK. RAB vector is minus 8I plus 6J plus 8K. Magnitude of AB is 12.806. Therefore, FAB is magnitude FAB times the unit vector of AB, which in this case is FAB times minus 8I plus 6J plus 8K. Divide this by 12.806. That will give me FAB vector in terms of IJK minus 0.625 FABI plus 0.469 FABJ plus 0.625 FABK. I now have the two forces in the cables in terms of IJK. The applied load, FAPP, is minus 100K. W is equal to minus WJ. And it said in here that the beam holds a 200-pound compressive load. Yeah? So that would be F of the beam would be 200I. So if I were to draw a free body diagram of this, I'm going to show a 100 cable tension FAC, cable tension FAB, and a force from the beam, which is compressive, pushing up against the joint, and a weight downward. That would be my free body diagram. In the statement of the problem, it said the beam was pushing, basically a compressive force, which is pushing against joint A. If it was a tensile force, it would be pulling on A. Yeah? So do I have all the force in the IJK format? Yes, 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 yes. Okay, now what? Well, now I'm gonna do equilibrium. Sum of the forces in the x equals 0, positive in this direction. Put all your eyes together. Minus 0.848 FAC minus 0.625 FAB plus the 200, which is the compressive load, equals 0. Some forces in the y equals 0, positive upwards, 0.318 FAC plus 0.469 FAB minus W equals 0. Some forces Z equals 0 coming out of the paper positive, minus 0.424 FAC plus 0.625 FAB minus 100 equals 0. What do I have? I have three equations in three unknowns, FAB, FAC, and W. Three unknowns, three equations, right? Solve. If I solve, I'm going to get here W is equal to 125.055. FAC is equal to 78.62. FAB is equal to 213.34. Done. That wasn't so hard, was it? Any questions on what I just got through doing? Questions? Anything bother anybody? Now, come test time, there is no thought process. You must read, react, and start writing. You can't sit there and go, whoa, shit. What was that? Theta was... No. It's got to be snap, 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 snap. That's when you know your shit. So those of you doing the testing manual, if you're doing the testing manual, do not go back into your notes and figure out, forces must be additive when it's parallel. Or no, forces have, you can't do that. You gotta know. How do I project a moment onto the line? Use a vector line dotted with R cross F. You gotta know. There can't be a, what was that? What do I do here in this? That means you don't know. So you gotta read, react, and start writing. It can't be, let me think about it. Your thought process to be quick. It can't be, let me pause and ponder it for a little while. You don't have the time. This is a simple problem. It's got parts A through E. And I left out part F, but I added later. That's what you should be thinking about. That's what you should be going, this is what he's going to do to you. I am telling you what I'm going to do to you. And I told you from day one when we first met, first day of class, I said, listen, I grabbed from chapter 4, chapter 3, chapter 2, chapter 2, section 9, chapter 2, section 7. I go back and grab from chapter 4, section 5. Put it all into one problem. That's what I do. I'm telling you what I do. It's not a secret. And if you don't know your shit, you're going to run out of time eventually. So be careful. And you think you kind of know it, but you really don't. I want you to take at least 2 of the testing questions 2 of them. Okay? Take the last 2. I want you to put 2 hours on the clock. And I want you not to look at any notes or videos or whatever. Just you, the test, the calculator, the pencil, the eraser. That's all I want. Put a timer, 2 hours. Once the 2 hours is set, stop. Don't look at anything, don't talk to anybody for 2 hours. Practice it. Because that's all you get here is 2 hours on the 27th. So try it. The last 2. Last 2, do not look at any notes. Time yourself for 2 hours. Did you finish it in 2 hours? Did you know what you were doing in those 2 hours? Or did you have to stop and pause and think about it and go, damn, I wish I had my notes. If you can finish it in 2 hours, the last 2 exams, then you're probably ready. If you can't, you're not ready. So when I was in your shoes, I literally did this. I studied like crazy. One day I studied all the concepts. The next day I did problems. The third day I did more homework problems, just homework problems. Fourth day I went to the classroom. I sat in the exact same seat I'm going to sit during the exam. I put 2 hours on the clock, actually it was about 1 hour and 15 minutes. And yes, in the old days we could find old tests. And you paid for it. I took 2 old tests and I sat in my seat, the same exact seat that I want to sit in during the test. And I did them and I timed myself. Literally, it's exactly how I prepped for my tests. One day, all the concepts were used. One day, more problems, random. I just grabbed some from the textbook and did them. But one day, I sat in the exact same spot I'm going to sit in during the exam and took a timed test. Or 2 if I could find 2 or 3 or whatever I could find. Hell, I made this life easy for you. I gave you 7 of them. You don't have to go hunt for them. They're right there at your disposal. So all I'm asking you is take 2 of those, the last 2, they're pretty good 2 ones, and time yourself. No notes, no nothing, 2 hours. Can you do it? I don't know. But it would be an interesting experiment for yourself. And if you can't do it in 2 hours, you ain't ready. Pretty simple. Okay? Let's finish this problem. So next, I want to find the angle between. Okay. That's chapter 2. So this is chapter 3. This was all chapter 2. Here comes chapter 2, section 9. Theta is equal to cosine inverse of RAB dotted with RAC divided by the magnitude of RAB, magnitude of RAC. Please note, there's no extra work in this problem, this particular finding the angle. You already have the R, don't you? All I have to do is dot it. All I have to do is dot and divide by their magnitudes. So this is cosine inverse of, if I do the dot product, I'm going to get 64 plus 18 minus 32. Divide this by 9.434 times 12.806. Doing this, I'm going to get 65.6 degrees. Could I do the forces? Yes. Force AB dotted with force AC divided by the magnitude of FAB and FAC. Cosine inverse. I can do the forces. I don't want to do the forces. That's an extra piece I don't want to deal with. Why? Because I now have to take FAC 78.62 and multiply it times the 0.848, the 0.318, the 0.424, then square, add it, no, I already have that, 78.6. But that's an extra step I don't want to deal with. So I did the R's instead. Okay? Next, hey, I need to find the projection of AC onto line DE. Well, the first thing I have to do is find FAC. Well, that's going to be 78.61 or 62 times minus 0.848 I plus 0.318 times 78.62 J plus, or actually minus 0.424 times 78.62 K. I rounded, FAC is equal to minus 66.66 I plus 25 J, it's like 24.99 minus 33.33 K. There's my force, FAC, that I'm trying to project onto line DE. What do I need for DE? I need the unit vector DE. Well, first I need to find the position vector. So the unit vector DE is equal to RDE divided by magnitude of DE. That's going to be XE minus XDI plus YE minus YDJ plus ZE minus ZDK, and I'm going to divide that by the magnitude of RDE. That is really 2I plus 0J minus 8K, divide this by 8.246. That's equal to 0.242 I minus or plus 0J minus 0.9702 K. So the projection of FAC onto DE is minus 66.66 I plus 25J minus 33.33 K, and I'm dotting this with 0.242 I plus 0J minus 0.9702 K. That projection comes out to 16.7. 16.7. That projection comes out to 16.7. Yeah? What did I do here? Chapter 2, one of the uses of dot product, besides finding the angle, is find a projection of a line, of a force onto a line, or any vector onto a line. Unit vector of the line dotted with the force.
Bless you.
Yeah? Again, this is what I'm going to do to you come 227. I'm literally gonna jam stuff down your throat. And I got 3 problems to jam a bunch of stuff in there. So when I tell you there's nothing missing on the test, there's really nothing missing on the test. Will he give me a double project? Yes. Will he give me an alpha beta? Yes. You think he might give us alpha beta and not give me a gamma? Yeah. You think they'll be in equilibrium? Yeah. You think they'll be pulleys? Yeah. Blocks or England? Yeah. Springs and series? Yeah. You think it'll ask me to project? Yeah. Forces and moments. Yes, 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 and yes. What's missing? And again, you have 7 sample tests to go on. But I'm not hiding it. What's the first problem you're going to do on 227? Problem number 3. Because that one ain't changing. It's not changing. The diagram's going to change, but it ain't changing. So for example, here's one that's in your help session problem. Please notice, what does it say? 3. It was question number 3. Let me guess. It's going to say, hey, write all forces in rectangular Cartesian coordinates. That's A. B, find me a moment. I don't know what it says. Could be a moment about OA, about the coordinate axis. It doesn't matter. It's find me a moment. Do me an R cross F. Next is probably going to say find me a force about some fucking line. What that line is, I don't know because I haven't seen the problem. Then it's probably going to say find me a moment about some line. Then it's going to say, hey, reduce the system down to a single force, single moment. Is it possible to go down to a single force? If so, locate it. What's it say? Forces in Cartesian vector form. Check. Moment of the 50-pound force about the origin. Check. Project FAE about, oh, the line is OD. And if I had seen the diagram before I started rattling it off, I could have told you I dotted this to show you where OD is. So as soon as I saw the diagram, I know I'm going to do a moment about a force about OD and then a moment about OD. What does it say? Oh, 5-minute moment of FE about OD. What's the last thing? Replace the system. That question never changes. The components of that question is always the same. The 50-pound force might be something else. FAE might be FAD. Line OD might be line AD. But it ain't going to change. And it's going to be a 3D problem. Which means the first step you do is what? Coordinate system. Then you ask yourself, hey, how many ways did he give me this information? Well, let's see. Couple projections. 1. Alpha, beta. Fuck, he didn't give me gamma. Wonder why. How do I do that? There's your identity coming into play, right? And of course, the 200 is along AE. Now you have to do the 5-step process to get AE in terms of IJK. Did I tell you he might give you all 3? All 3 ways to give a force. Did I say I'm probably going to do that? Did I say that to you? Did I do it? Okay, so where's your fucking beef with me? Any of these questions, have I covered them in class? Okay, so where's your beef with me? Oh, no, he's not to fail me. Really? How can people say that? It irritates the fuck out of me when people say, oh, he just wants to fail me. He gets joy out of failing. What? If the university gave me more money to fail people, I would be failing people left and right, for sure. But they don't give me any more money. Actually, they're pissed off that I fail so many people. I actually was brought in. Hey, Professor Norton, yeah. Your DWF rate's too high. What? your DWF rate's too high. Your DWF rate's up at 32%. I'm like, and? But we'd like to have it lower. So you want me to sugarcoat the class? Want me to make the class easier? Oh, no, that's not what we're saying. But your DWF rate's too high. I said, let me ask this. What's the university want for a DWF rate? You know what their answer was? 10%. I'm like, I'm so far away from 10%, I even know it. I'm 32, and by the way, I'm not the highest. There's one person that's 33 that pisses me off that I'm number 2. I like to be number 1. They actually said I should bring it down. You know what my response was? My response was, you tout every fall semester. Our incoming class has a 4.8 GPA from high school. SAT score 1,500. Blah, blah, blah. Whatever the fucking numbers are. Supposedly great. I said, how about you give me some students that want to work? I don't give a shit about their GPA in high school because that was, oh, it's okay, honey. Do the problem again. I'll give you extra problems. I feel good. I'll give you an A. Don't worry. Mommy calls and says, hey, he needs an A in order to get into Harvard. So they give an A. That's what's happening. That's exactly what's happening. So I say to them, and literally I said to them, why don't you give me students that want to work their ass off? I don't give a shit about their GPA. I don't give a shit about the SAT score. Just give me kids that want to work. I'm okay with that. I don't give a shit if their SATs are 1,000. Are they willing to work? Put in the work to get the damn job done. If they are, that's the kid I want. That's what I want. So I did lower it. It's down to 25%. You know why it's lowered to 25%? Mastering lowered it. Because you guys get the 90s and the 95s and the 100s and so forth. That balances out those 61 averages on the quizzes. That's how I lowered from 32 to 25. The best. Have my quizzes been any different? No. Have my tests been reduced in difficulty? No. And I'll never, and I told them that. I said, I'm never going to get to 10%. It's not going to happen. Hell, I don't think I'll break 20%, honestly.
What did they say to that?
They were baffled. I could see the face and go, like, huh? What do you mean you're not going to reduce it? So wait, here's the best part. The best part. I go to a meeting, and in the meeting, this was in the fall, right before fall ended. Topic of the meeting was grade inflation. I'm like, well, we have 900 students on the meeting. I'm like, okay, what's the problem? There must be grade inflation. We're not doing a very good job of pushing our kids. I'm like, wait a second. I was just brought in because my DWF was too high. Well, no, we're not talking about you. We're talking about other professors. That's what they told me. Can you please decide what you want? Do you want A's and B's? Do you want D's and F's? What the hell do you want? I'm confused. Literally, we talked for an hour about grade inflation in the College of Engineering. I'm like, I literally, after about 15 minutes, I raised my hand. I said, can I be dismissed because this topic doesn't relate to me? And I was trying to be funny. They didn't think it was funny. They have no sense of humor. That's okay. Gupta from chemical. There's also a person from computer engineering who's tied with Gupta. So I guess technically I'm number 3. Damn, that sucks. Try something. Next Friday, this is the problem I'm going to do. So put a timer on it. See if you can do it in 30 minutes. Break problem to test your ability to do the problem. Okay? And then you can check your answers when I go through it on, what's everybody getting up for? Wait a second, I still have to finish this problem. So check your answers, make sure you're okay. I have one more section here. Oh, and I'm doing this problem next Friday too. Those 2 problems are old questions from old tests. Question number 2, and then the other one was question number 3 from the same old test. FAC. Easiest R you could take is O to A, which is 8I. So all I do is say 8I crossed with FAC, which is minus 66.66I plus 25J minus 33.33K. Do this and you will find 267J plus 200K, and I round it. That would be the answers to this question. Any questions? Any questions? Is anybody stuck on anything? Yeah. I need an R that goes from my moment center. What's my moment center? Oh, I need to go from the moment center to any point on the line of action of the force. Well, it's A on the line of action of the force. And that's the easy one because it's only made I. Again, the R I chose, I could have chosen OC, I could have chosen these guys, but I don't have these guys. The only other good one would be AO or OC. I chose OC because I only have one complement, AI. AI, sorry. Questions? Thoughts, comments, ideas, anything bothering anybody? All right. Close them up.